Hi, today I want to explain how to do time series regression on Spss. So first, we import some data from the computer. Here we importing data in CSV format of airplane passengers. Just click OK. So I want to change the variable name of the passengers to air passengers. Since the time series analysis requires the time variable to range from 1 to n, we make n index column which is months from 1 to 144 for our case. So it's 1, 2, 3, 4, 5, 6, 7 until 144. Okay, next let's plot the data to see whether this data has constant seasonal variation or increasing seasonal variation. So you have to click graph, then chart border, and then you have to change it, and then you have to choose line. Click for the first box and drag upward. So for the y-axis, you take air passengers, and for the x-axis, you choose months. Then click OK. So here, this is the graph. You can double click on the graph if you want to edit the title. So I want to edit this title to air passengers against month. And for the mean air passengers, I want to change to air passengers only. From this graph, we can see the increasing seasonal variation, so we need to do transformation. We have chosen to do natural log transformation. Then check again for the seasonality by plotting the graph. So you have to define a variable which is ln air passengers. And then you have to choose arithmetic and choose ln. In the bracket, you take air passengers and click OK. So next, for check the seasonality, you have to make a graph. The same step. So the y-axis, we have to choose ln air passenger. So the same thing, if you want to edit, just click. Just click, double click. So I want to change this graph to load air passengers against month. And this one I just want load air passengers. From this graph, it already shows that it has constant seasonal variation. So with the transform variable, we can perform regression. Since we are dealing with a time series, it's worth checking for autocorrelation. So with our working variable, we check for autocorrelation before any modeling. So you have to click analyze, then first and choose autocorrelation. So for this part, you choose month and learn air passengers. Actually, month is not important. The most important is learn air passengers. So here's the output. Like what I said, the month is not so much important. So this is the learn air passengers autocorrelation. Next step is to construct the seasonal dummy variable. We have to start with the first month. So first, you have to define the new variable, which is S1. And for this, you click 0 if condition include all cases. And then you click continue. And then you change 0 into 1. And condition that if case satisfied. So you have to choose mode for months and for 12 months and equals to 1 and click OK. So if you can see, we get 1 for months 1 and the next multiple of months 1. So the same step for S2, which is second and the last month. Since we need L1, L minus 1 dummy variables. So this is the last month, the same step we doing. So I don't want the decimal places, I just change to 0. So for the seasonal dummy variable, we have to do linear regression. So for the dependent, we choose lone air passengers. And for independence, we choose month S1 until S11. So for the statistic, we choose coffee interest interval, skip this, and the important Rubin Watson. So this is the output. So this is the new coefficient. This is the important thing of the regression. So back to the data. So now we will visualize our model and compare it with the data. One way to do this is to define a new column for the estimated values. We define them based on the coefficient of the model we got just now. Minus months times the t, which is 0.10. So we have done put the relation of the data, and you choose the condition for all cases and click continue and click OK. So now we have the column of the models. Next, we make a graph for the two columns together, which is the data and the models. So first, you have to choose multiple graph. So for the line represent, we choose lone air passengers and the models. And for the variable, we choose months. And then click OK. You can change the color if you want, just double click. So from the graph we have here shows fits closely to the data. However, since the Rubin-Watson statistic is small, we still have autocorrelated residuals. This means that our model is still inadequate. So we still need to improve our model, but we can define the new variable just as we did with the dummy variables and then put them in the model and continue similarly. We can try trigonometric variable, t square, square root of t, and etc. We compare to choose the out with the best Dolby Watts statistic and are to adjust. That's all.